Hi, my name is Johnny and I'm one of the PMMs here at Check Point CloudGuard, and in this video I'll review what Cloud Infrastructure Entitlement Management, or CIEM, looks like with Check Point CloudGuard, starting from compliance enforcement through to machine learning-powered identity and access management, as well as using cloud detection and response to spot privilege escalation, including ones originating from third-party sources. But before we start, I'll just remind you that cloud security is just one of 3 offers by Check Point, all of which are under our single unified Infinity umbrella. Digging deeper, you can see that Check Point covers all aspects of enterprise cybersecurity, while Check Point's cloud-native security solution, CloudGuard, includes in it 3 complementary modules: our Cloud Network Security, which is a cloud-adapted version of our award-winning next-gen firewall, which includes complete access control enforcement, intrusion prevention, VPN support, and identity awareness; our cloud-native security platform that offers simple agentless onboarding, cross and inter-cloud visibility, automatic compliance enforcement, incident response, and more; and our groundbreaking zero-day prevention web application and API firewall. Expanding the picture, CloudGuard's core CNAPP modules prevent risks from R&D to runtime, and is bolstered by additional breach prevention modules guarding attack surfaces at the points of contact with public and private networks. Now, when it comes to the various aspects of entitlement management, from compliance to detecting privilege escalation, a full cloud-native protection platform is really the only way to address it properly. Starting from enforcing compliance in code and infrastructure as code artifacts, to continuous compliance enforcement across clouds and assets, ensuring minimal access to sensitive data, detecting anomalous identity behavior in workloads, and then with CDR, or Cloud Detection and Response, detecting everything from privilege escalation to suspicious login attempts, and even changes in actual admin roles of the cloud account itself. And only then, when you have all these solutions in place, can a full machine learning-powered CIEM do its job of ensuring least privilege enforcement before runtime, during runtime, and across all assets and clouds. And you will see these in action shortly, including a use case, product tour through the modules, a real-world attack analysis, and finishing up with a demo. Now, to show why having a full end-to-end CNAPP is key to a full CIEM solution, I'll actually start with a customer story. And I picked CSU because it doesn't just demonstrate the interplay of different CNAPP modules, but also the gradual implementation of CNAPP modules as the cloud adoption matures over time, starting with the bare minimum, compliance enforcement, which CSU managed to get in 90 days to 98% compliance across assets. And remember that almost all compliance frameworks put a strong emphasis on configurations related to role and identity privileges. And indeed, you can see that the first solution they adopted before CIEM was the CSPM/DSPM and workload protection. Now, while workload protection is related to privilege and access control management, especially by looking at serverless runtime permissions and privilege escalation within a workload, it is beyond the scope of this video. CSPM and DSPM, on the other hand, which are in charge of compliance enforcement, are strongly coupled to the enforcement of the principle of least privilege, since proper compliance enforcement will probably prevent almost any violation of least privilege, and even assuming privileges in some cases, and this is because that even if you must have some highly privileged role somewhere that is risky, proper segmentation configurations, for instance, can at least limit the options an attacker has to abuse a privileged role. Now, our CSPM has, in the last count, around 420 rule sets covering frameworks, best practices, regulations, audit checks, and more, covering AWS, Azure, GCP, Oracle Cloud, Alibaba Cloud, and Kubernetes, and of course allows for custom rules, as well as automatic remediation and continuous enforcement, which in our case involves just clicking a framework, and with another click apply our cloud bots, and anytime something violates a rule, it will revert to what it should be. But still, CSPM, while including many of the CIEM functionalities in its policies and engine, is just the start of the story. So to see the rest, let's jump to CloudGuard's main dashboard. And here at the top, I can see my toxic combinations that assigns risk scores to assets by merging all the findings from all my CNAPP modules, including the CIEM module, and chaining them together into plausible attack paths. For instance, if I have an overprivileged role, but it is applied to a VM that is fully patched, not exposed to the internet, properly segmented, and doesn't expose some valuable asset, it doesn't pose enough risk to require immediate attention, unlike this asset here, which is an exposed VM with an exploitable CVE and high privileges. And clicking on it, I can see all the assets that are affected by similar toxic combinations, and clicking one, I get a complete overview of the asset, including the CVEs that were found on it, the permission issues, and the full context in terms of a plausible attack path from the exposed internet node to where an attack might lead. Now, clicking on the permissions findings, CloudGuard takes me to the problematic role, and in the permissions tab, I can see the full daisy chain of this role's permissions across assets. And this JSON on the side is what the roles JSON looks like if the original one took everything you see here into account, and we'll get back to this view shortly. But for now, let's go to a more standard CIEM flow where I start from our dedicated CIEM module dashboard. And you can see our CIEM draws information from cloud account roles, serverless permissions which are inspected at the code and runtime levels, and Active Directory or Entra. And this is also where you can see the whole CNAPP interplay, where we have CIEM-related findings from across CNAPP modules, including risky permissions, password policy violations, non-human identities, and inactive roles, as well as runtime findings from our workload protection and detection and response modules. And everything together is configured with one goal in mind: ensuring least privilege and zero trust are enforced and maintained everywhere and at all times. Next, I want to review something that we emphasize beyond just findings, which is security practitioner empowerment. So again, looking at the permissions of a given role, you can see what my cloud engineer configured, only in this case, my cloud engineer is AWS, which is usually a bad idea since default configurations are meant for ease of deployment rather than for ensuring security. And you can see how dangerous this role is when I sum over the privilege daisy chain, which gives you a different view of what this role is and what it can actually do as opposed to the bare configurations. And what CloudGuard does is to give the security practitioner the precise JSON they need to apply if they want to fix the issue. And from there, they can copy or download it, apply it themselves if they can, or send it to an engineer, knowing that least privilege is taken care of by security experts rather than cloud engineers. And this JSON is where machine learning kicks in, since CloudGuard's CIEM module learns your cloud assets' interconnectivity and the permissions required by each asset and function. So what you get is least privilege not based on some generic algorithm, but rather based on how your cloud's assets really behave. Now, another place you can see all the CIEM findings are in the Events page, where I can click the CIEM tab, and clicking on any of the findings will lead you to the same view but in a slightly more accessible way. And this is a good chance to see what it means to sum over the privilege daisy chain, because when you zoom out to look at what a role actually has access to, it can be a bit dizzying. So you can just click on the consolidated view and see exactly the type of access and boundaries that are set for each asset in your cloud, which again goes back to the interplay between the narrow CIEM functionalities and a broader view of a full cloud-native protection platform deployment, because without this level of visibility, discoverability, and observability across clouds, including inter-cloud connections, your CIEM is useless for modern cloud deployments. Now, the last thing I want to touch upon is cloud detection and response that collects and correlates network and account activity logs across all clouds with other CNAPP findings and then checks them against MITRE ATT&CK and indicators of compromise from Check Point Threat Cloud AI to find things like, in this case, where suddenly a user got to be the owner of this entire Azure subscription. And by the way, when something like this is found, you can get alerts in your SIEM, ticketing app, or Slack, or Teams, and if it passes a certain threshold of severity, or based on policies, it will be auto-remediated. But it's not just obvious issues like this that CDR can detect, but also more obscure cases like here, where access tokens were added to an app, which can then be abused for privilege escalation. Another way to see why a full CNAPP is superior to a narrow point solution is to look at an attack and see how it could be prevented. And this specific case involves a cloud-first bank, a disgruntled ex-AWS employee, a misconfigured WAF, excessive privileges, a cloud service provider service with known issues, and a whole lot of sensitive data, which ended with a breach that cost the company a whole lot of money. So here's what went on, and I'll just preface this by saying that this is very far from a technical breakdown of the attack. But anyway, it all started with a misconfiguration of the WAF that made its proxy directly exposed to the internet. So basically the WAF instance itself was accessible through a public IP. And this is something that our CNAPP visibility engine would have immediately spotted as an exposure risk. Now, not only was the WAF exposed, its role also had excessive privileges that allowed it to prod AWS's old Instance Metadata Service, or IMDS. Now already here, our CIEM would raise a flag and say, listen, this role doesn't need this level of access. And of course, the CDR would scream out that this never happened before and mark it as severe, since IMDS is a highly sensitive component that can provide an attacker with full cloud inventory, including temporary access tokens. So at this point, your dashboard would go into panic mode. Regardless, abusing the WAF excessive permissions, the attacker queried the IMDS, and unfortunately the old AWS IMDS had no way to validate request authenticity in the request header. And that meant that it was vulnerable to server-side request forgery attacks. Now in this case, because Threat Cloud AI knew this is an issue, this incident risk score would have shot through the roof and the CNAPP would probably automatically sever the connection preemptively. But in any case, the attacker forged the requests and the IMDS did its job and gave the attacker access tokens to a database that contained the most sensitive data a bank can have. And this access request would have then been stopped by access configurations imposed by the CSPM and DSPM modules. And just by looking at the path and the list of issues on the side, you can see why CIEM alone is incomplete. And one last point I want to make is about CloudGuard's unique breach prevention engines that, even if all else failed, would have stopped the devastating results of the attack. In this case, with the data leak prevention engine built into our next-gen firewall. And with that, let's close this video with a quick demo of the CIEM module end-to-end.
Okay, now let's take a look at a toxic combination with a focus on the high permissions part of this alert. Our CIEM engine allows us to begin solving this issue by understanding the permissions that were granted. The affected asset here is the CG WAF single gateway, which is marked with an IAM sensitivity score of 99. And what does this mean? Well, it represents the possible damage that current IAM permissions can cause to the cloud environment if they're exploited. Here I can see both the role attached to this asset as well as all of the policies that have been deemed as having high IAM privileges. These are broken down by both their action, the policy, and the scope. Now let's explore the role here. So if we go into the context graph, we can actually break this down and see the details of this IAM access. Now, as we continue to investigate this issue, the presented entitlement map allows us to see that the Amazon SSM role, for instance's quick setup role, is connected to two AWS managed policies deemed critically and highly overpermissive. And these have access to various resources and services. For example, the Amazon SSM Managed Instance Core policy has SSM services that are connected to it. Now, what is an AWS SSM service? AWS Systems Manager is a fully managed service that enables you to manage and automate your AWS resources, such as running automation tasks, patch management, executing EC2 commands remotely, and more. Now, you'll notice as I click on these services that the JSON on the right actually changes to highlight what part of the permissions we are actually looking at. Now, looking at the original permissions, it shows the policy as it's defined in the cloud platform. However, these policies can have permission boundaries and service control policies that affect how the original policy behaves. In this case, the original and the effective permissions are the same. And as written, you can see that the SSM permissions allow a huge number of actions across any resource. And now that we understand the overpermissive policy, let's click on the suggested policy to see how CloudGuard guides us towards the principle of least privilege. Note that the SSM actions have been specified. Instead of get describe list put permissions to any resources, we can now only perform these actions on specific resources. And to make my life easier, these improved permissions can actually be copied or downloaded for immediate use. So how does CloudGuard create policy suggestions? Well, our CIEM engine routinely completes scans of your identities and their permissions, comparing the granted permissions to the effective permissions. And for identities whose behavior is harder to predict, such as a SAML federated user, CIEM uses machine learning to build a baseline of the behavior of an entity. Once this baseline has been established, CloudGuard then provides suggestions to reduce the access rights. Now, the Alert Details button links me directly to the finding overview, where I can see the alert indicating excessive permissions. It also will show me my remediation options. Option A is that we can update the existing policy with a suggestion. And you can see this for both of the roles that were attached to this policy. Again, these can be copied and or downloaded. The second role would be to add a suggested permission boundary. And perhaps most important of all, the redundant permissions view exposes permissions granted but not in use. So you can see the original permissions versus the suggested, and this can be broken down by severity as well. And in case of attack, eliminating these permissions can go a long way in limiting the potential for malicious lateral movement in your cloud environment.